David Caldwell. David Caldwell. All right. So today I'll be explaining how cells produce and handle three different macromolecules. A lipid, cortisol, which is a steroid hormone, a secreted protein, which is going to be growth hormone, and an intracellular protein, which is actin. Each follows a distinct pathway inside the cell involving different organelles and ending up with different fate in or outside the cell. First, we're going to start off with cortisol. Cortisol is made from cholesterol. The cholesterol supply comes from either from LDL particles taken up by the cell, from the de novo synthesis, or from lipid droplets stored in the cell. The first major step happens in the mitochondria, where the transport protein called STAR shuttles cholesterol inside an enzyme called P450-SCC, which you see here, then converts cholesterol into pregnenolone. Next, the pregnenolone moves to the smooth ER, where a series of enzyme reactions modify it further. Then it cycles back to the mitochondria, where the final hydroxylation steps occur to make cortisol. Once synthesized, cortisol is lipid soluble, so it simply diffuses across the plasma membrane without needing vesicles. Finally, in the bloodstream, cortisol binds to carrier proteins and travels to target tissues, where it binds intercellular receptors and changes gene expression. Next, we're going to do our growth hormone right here. It starts in the nucleus, where the growth hormone is transcripted into mRNA. Right here. The mRNA goes into the cystole, and a signal peptide directs the ribosome to the rough ER. Translation continues directly into the ER, where the protein is folded, forms disulfide bonds, and receives early glycosylation. Next, the protein is packed into the COP2 vessels and transported to the Golgi apparatus. Right here. The Golgi acts as the cell's post office, further processing and sorting growth hormone. From there, the growth hormone is packed into secretory vesicles, which store it until the cell receives a stimulus, like a rise in calcium levels. Finally, those vesicles fuse with the plasma membrane, releasing growth hormone by exocytosis into the bloodstream. Once in circulation, growth hormone binds to receptors on target cells, activating pathways like JAK and STAT, which stimulate growth and metabolism. Now, for our last one, we have actin, our intercellular protein. Actin production begins in the nucleus, where the actin gene is transcribed into mRNA. That mRNA is translated by free ribosomes in the cystole, because actin is not destined for secretion or membranes. As the protein emerges, it is folded with the help of the chaperones like HSP70 right here, CCT, and this produces actin monomers, or G-actin. The cell carefully regulates these monomers with actin binding proteins, and when needed, actin monomers polymerize into filaments, which with the help of ARP23 complexes and formations. The final fate of actin is as part of the cytoskeleton, where it provides cell shape, supports intercellular transport, and drives motility. In conclusion, to summarize, lipids like cystole are synthesized mainly in the mitochondria, and smooth ER, then diffuse out to act as hormones. Secreted proteins like growth hormone follow the classic endomembrane pathway: nucleus, rough ER, Golgi apparatus, vesicles, and then exocytosis. The intercellular proteins like actin are translated on free ribosomes, fold in the cystole, and remain in the cell as part of the cytoskeleton. Together, these examples highlight how cells tailor different pathways depending on the type of macromolecule and its unlimited ultimate destination. Thank you.